Good day, everyone. Today we'll tackle about Pythagorean theorem. Pythagorean theorem is one of the most fundamental and basic theorems in mathematics. It defines the relationships between the three sides of a right triangle. So what really is Pythagorean theorem? We are already aware of the definitions and properties of a right triangle. So, in one of the side or one of the part of a right triangle, there is a perpendicular angle or the angle which is a right angle. That means that it measures 90 degrees. So, the side of the other side, which is the opposite of the right angle, is called the hypotenuse. So suppose this is the right. We have here the right triangle. And this is the right angle that is being formulated in a right triangle. Since we're talking about the right triangle, it measures a 90 degree. There is a 90 degree angle. And this is the hypotenuse. Hypotenuse, which is considered also the longest part of a right triangle. Now, this is the adjacent, the legs or the sides. This is the adjacent to the right angle. So these are called the legs of the right triangle. We're being introduced to Pythagorean theorem. Pythagorean theorem is very important. So especially when we are using it to find the length of the side of right triangle. The Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the perpendicular and the base. So that is the c squared is equal to a squared plus b squared. So c squared is considered here the hypotenuse, a squared is the perpendicular, and b squared is the base. Now, since we are now being introduced to the Pythagorean theorem, we are going to derive how they are derived. We're going to discuss now on how Pythagorean theorem is being derived. Now we'll be moving on to understand how Pythagorean theorem is being derived. So this is similar to that of a plus b the whole square. As for the derivation, we'll start here. Let's draw a line. So this is the line. We'll be going to draw a mark here, a point mark. So this can be anywhere in the line. You can put the markings anywhere on the line. We'll be going to mark each point as B, and this is A. So now we'll be going to define this side as A plus B. We'll be going to continue now. We'll be going to draw a large square. Okay, we'll be using other marks, other colors, so that we can be able to identify the marks. So we'll be going to mark the other side. We'll be continue to mark the other side. Same. 1, 2. Okay. So these are the 4 marks. We'll be going to mark all of this side as A plus B. Since we're forming a square, they must have the same measurement. So we'll put here A plus B, A plus B, and A plus B. Okay, so these are the measurements. So the same as the one side here. Now we'll continue to mark the sides. So we put here B, A, B, A, B, and A. Now we'll be going to join the adjacent points here. So already formed a square. So as for this square, we'll be going to mark each side as C centimeters. C. So since it's a square, they must be the same. So this outer square has 5 parts. So this is the outer square, which already now has 5 parts. So these are the 4 right triangles contained, and a square that is measured in C centimeters, and also the height A, and the base B. Now, we'll be going to find its total area. Okay, so this will be the area, or the total area, is equal to the area of the 4 right triangles plus added to the area of the small square. Okay, we have here the total area, which is A plus B squared. So we have here A plus B squared. So where did we get A plus B? Is here for the outer square. The A plus B here. Since we're going to find the area, since the area of the square is equal to the square of its sides. So as for the area of the 4 right triangles, we have here 4 right triangles formed. So we'll know that the area of the triangle is 1/2 base and height. So in order to join the 4 right triangles, we're going to multiply 4 by 1/2 AB. Added to the area of the square, so we have C as its side, so it will become C squared. Now, let's move on to performing the operation. A plus B squared here will be equal to A squared plus 2AB plus B squared is equal to 4 times 1/2 AB will become 2AB plus C squared. Okay, we'll be going to join. There are other ways in solving this one, as we're going to join or perform the operation, the transpose. But for here, we're just going to cross 2AB, because if we're going to transfer 2AB here in this side, it will become negative 2AB, so which makes it 0. Okay, we're just going to cross this out, and what remains will be A squared plus B squared is equal to C squared. So here, this is now the Pythagorean theorem.
Pythagoras' theorem can be solved in many ways, and you have seen it previously. Here, let us look another way in which we can do it. So first, we will draw a square. This square has a side of C units. Next, we will draw a right triangle. So this is a right triangle. So this base is equal to A, and this is equal to B units. So we need to prove that A squared plus B squared is equal to C squared. So as this is a square, so this side is C, and we will complete the right triangle. So here, this is a right triangle with a base A and B units. So, in a similar way, let us construct a right triangle here. So, this is a right triangle with a base of A, B, and C units. So, in this side, this will be a right triangle with A, B, and C units. But what we are interested in finding the area of the larger square. So we all know that the area of the square is equal to side times side. Since the side of the larger square here is C units, so it is C times C. So C times C is equal to C squared. So the area of the larger square is equal to C squared. As we look closely, we can notice that there is a square, a little square or the small square in the middle of the larger square. So the area, to get the area of the larger square, we will add the 5 figures inside the larger square. So we have area of the larger square is equal to the 4 area of the 4th triangle plus the area of the smaller square. So this smaller square is equal to the length of the smaller square is equal to A minus B. Because A here, so this is the A and this is the B. So we can say that this area is A minus B. I mean this length of the square is equal to A minus B. So next, so 4, so the area of the triangle is equal to 1/2 times base times height. So our base is the A plus times our height is the B plus the area of the square or the smaller square is equal to A minus B times A minus B. So this is the area of the smaller square. So next, we will work this out. So cancel, so 2AB. So we will multiply A minus B times A minus B. So plus A squared minus or negative 2AB plus B squared. So since AB minus 2AB is equal to 0, so we will cancel this out. So A squared plus B squared. So we all know that the area of the larger square is equal to C squared, so we put it here. Thus, we prove that the Pythagorean theorem of C squared is equal to A squared plus B squared. So, in getting the length or the hypotenuse of the right triangle A, B, C is C squared equals to A squared plus B squared.